Hello, everybody. Welcome to the EMC live stream, episode 4. We've got a wonderful day today because we have my friend from one of my classes, Mr. Mr. Blake. Oh, it says Victor. I'll fix that. While you, Blake, quickly tell us something about yourself.
I'm Blake. I like track. I like math. I've been doing EMC for quite a while now, maybe 5 years, and it's been very fun. So,
Awesome. Okay. That wasn't enough time. It's okay. It's almost enough time. This is why we have this soft launch week so we can work out little things like this. Okay. Says Blake now. You are now Blake. Congratulations, Blake, on becoming yourself.
woohoo.
Awesome. Okay. So, so Blake, sir, we're gonna have a little bit of fun today. Our goal is to do some warm-ups next. So let's get into that. Hello there. Someone's in chat already. Hello, Octoon. Welcome. Okay, so today we're going to do some warm-ups, Blake. Let's look at this first problem. Well, what do you see first? What do you think we can do?
Um, can I turn it into like variables?
Make them variables.
All
Nobody's.
right.
We're old enough. We don't need no silly pictures of fruits.
We have 2x plus, let's say, n equals that, then 2x minus n equals that.
Okay, X is a apple and N is a banana.
Yeah.
Okay. Anybody in chat know what to do next? Feel free to jump in with the next step. Blake's already solved it in his head, I bet. He's that good. That's why I brought him on. Okay, Blake, what would you do next?
Next, let's see. How do I explain this? Can do well, we can turn this into not a mixed number, what's called improper fraction. So we can write
Improper. That sounds
30
good to me.
out of 21.
I'm not a big fan of the word improper, though. I think you know that. There's nothing improper about these fractions. They're totally fine fractions. There's nothing wrong with them. Okay, we've got improper fractions. We got
So
3 viewers. Welcome, viewers. Okay, so what can we do first, viewers, to solve for this problem? Today, by the way, is level 6, 7, 8. Grade 6 will find this a little harder. 7 should find this normal. 8s will find it pretty easy. Feel free to use chat to interact with us if you're watching. Okay, Blake, what would you do then?
well, the difference between these two is 27 21st.
Okay, so we find the difference. What's the difference? What's another name for difference? Or how do I find differences?
Like what you're or like the answer, like after you subtract.
Answer after I subtract. So we're going to subtract here. The whole thing, I think, might be good.
Yeah.
Okay. So if I subtract 2x minus 2x, what do I get?
0.
0. If I have banana minus negative banana,
2 bananas.
2 bananas. And then we're taking our 31 21st and subtracting 4 21st. So we have
27 21st.
27 21st. That's 2 bananas.
Yep.
What's 1 banana?
Well, since you can't divide 27 by 2, you can multiply the whole thing by 2, like the bottom and the top. So then we would get 54 40 seconds.
54 40 seconds.
Yes, and then you can divide that by 2, and you would get, if you divide that by 2, you get, see,
Right back where we were.
27 40 seconds.
27 40 seconds is 1 banana. Let me put that next to the equals banana. Nicely done, sir. Okay, how could I figure out apple then?
Well, you can just go backwards. So to 4 21st, start from the bottom because it's a smaller number. To 4 21st, you can turn that into 40 seconds. So this would equal 8 40 seconds. And then you can put your banana. You can add your banana by moving it to the other side. So then you can figure out just the 2 apples. And that would be 8 40 seconds plus 27 40 seconds, which ends up being, let me erase this, 27 40, that ends up being 35 40 seconds. So that's 2 bananas. Or, I'm sorry, 2 apples, right?
Mm-hmm.
And then we divide that by 2 because we need 1 apple. So we can just multiply the bottom by 2 to divide it by 2. So we get 35 out of 84.
35 out of 84. I bet that simplifies.
Yes, it does. That
Mostly because I
simplifies.
wrote the answer key.
5 12s, I believe. Is that right?
5 twelfths is correct. Okay, so the first thing we did, we made it variables. The second thing we did, we made it improper fraction. Then we took the entire top and subtracted the entire bottom to find 2 bananas is this fraction here, which means that 1 banana is double the bottom. And then we took our 27 40 seconds and put it to the other side of this equation to get 35 40 seconds, which means we have 2 apples. We're going to double the bottom. It's 35 84ths. And that's because I need to divide by 2 on this side, so I have to divide by 2 on this side, which will make it 84ths. Great job, Blake. Well explained. Okay, we're up to 5 viewers. Hello, everybody. Please use chat if you want to say hello and ask questions. We're going to get started on our second warm-up here. Tree times pig is 576. Fish plus tree is 14.5. And pig times fish is 468. Whoa. I got how many variables now?
3
Which means I need how many equations to solve it?
6, I think.
6, he thinks. What do you think, chat? How many equations do I need per unknown?
Might be a little wrong there.
How many equations did we need for 2 unknowns?
Was it 2?
Just 2? So 3 equations for 3 unknowns should be enough, I think.
C.
It's okay. Don't worry, sir. Let's figure it out.
Um,
Where would you
I
start?
turn this tree into an X because it looks kind of like an X.
Okay.
Let's put the
It looks more
pig
like
as,
a Y to me.
oh, we can make it a Y then. All right, we'll put tree as Y, pig as P, and fish as F. I feel like that makes it a little easier. So then we can have this top one can turn into Y equals 576 over P because we can divide by P to move it to the other side. And
Excellent.
just divide both sides by P.
Okay, so we got over P. We've moved the pig to the bottom by dividing.
And for the next one, this one can also have tree. So Y equals 14 and a half minus F.
Okay, so we've got one equation of Y with P, one equation of Y with F. What can I do to fix it?
Well, we can say that 576 over P is the same as 14.5 minus F.
Okay, that gets
So
me one equation with P and F. So we set these equal to each other, and we'll get 576 over P is equal to 14 and a half minus F.
yep. And then for the pig, basically do the same thing where P equals 576 over Y.
Okay, what's the point there?
Well, to solve for P.
Mm. We've already solved, we've already used P up here, right?
Oh, you're right, you're right, you're right. And
So
do
I should,
P equals 468 divided by fish.
P is equal to 468 over fish from this one. So I can replace this with 468 over fish. Okay, what's going to happen with that fraction? Does
Well,
anybody in chat know? Feel free to chat your answers. Blake is here to help when you guys aren't sure what to do, but we'd love to know what you would do next. Okay, Blake, continue.
well, you can just divide 576 by 468, which will give you, I'm not exactly sure. I can check. That will give you not very nice number.
Not a nice number. Of course, that's
But I'm
okay.
pretty sure that can be simplified.
It'll probably be simplifiable. Yep.
Or we can try to figure out what to do with these two F's.
Yep. What's going to happen when I divide by a fraction? With I have 576 divided by a fraction.
It's gonna get bigger or smaller. Depends how big
Depends on
F
what
is.
f is. But
Yeah.
how do I undo a division by fraction?
You multiply everything by.
Multiply by the reciprocal. Okay. So this is just going to cause it to flip,
Yeah.
which will just put the f on top.
Yep.
little trick.
All right, then from there,
What should we
um,
do to? I don't want to do a big ugly fraction. What should I do instead?
could just multiply the other side by 468 as well.
Multiply that other side by 468. And I gotta move that back on the screen for everybody else. Okay, chat, what would I do next? Chat's shy today. They think Blake's gonna do all the work. They're gonna give you all the credit. I think you were right. There's probably some simplification we can do here. So
Yeah.
let's remember our divisibility rules. Trying to do this without a calculator. If it ends in 76 and 68, what do I know these are divisible by?
Um, 2, definitely 2.
Definitely 2. So let's chop everything in half.
Or it's actually divisible by 4.
Chat says you're doing well. We want to see how he thinks. Okay. Cutting that in half, we have 250 plus 35 plus 3, 238.
And then over here you'll get 234.
Oh,
Yeah.
288. Sorry.
Then you can just divide by 2 again.
Divide by 2 again, which means they were divisible by 4 originally.
So let's see. Let me write this. 117.
117.
Right.
Ew.
Now we have 144f equals 14.5 minus f times 117.
Okay. So let's get rid of these old numbers. I can't erase that one. I'll scribble over top of it. Okay, 144 f is equal to 14.5 minus f times 17. Okay. Where to next, sir?
Well, we could just multiply everything, but that would be pretty difficult. So I would say you could divide everything by f, potentially.
Divided by f? Well,
Yes.
I think we
Well,
should
that's the multiply
probably
first.
distribute. I think
Yeah,
that's
that's
the next
good.
thing.
Yeah, and then divide by f.
Okay, if I distribute this, I got negative 117f. And we've got 14.5 times 117. Let's call that.
That's
And
100,
some number.
1696.5.
196 and a half. Okay.
No, 1696.
1696.5.
Yeah. Now we can definitely divide it. No, definitely all from my head.
All from your head? Okay, I believe you.
No.
I shouldn't believe him. Okay. And that's 144f. So how many f's make this ugly number?
Well, we could move these f's to the other side to just isolate the f's from the number.
Okay. 144 plus 117.
This is going to give you 261 f's.
Okay. I'm going to move down here. We got some white free space down here. 261
Yes.
fishes is
1,696.5.
let's use that calculator again. Nobody knows how to divide by 261, right? No, we know how. We would use long division, but we're not here to waste your time and my time.
Now I'll give you 6.5.
6.5. Fish is 6.5.
Yep.
What a nice number after all that work. Okay, we can clear this off.
And then from here,
We get our trickle down effect or trickle up effect. 6.5 for fish.
Yes, so we could just rewrite this fish as 6.5.
Mm-hmm.
And then 6.5 plus the tree would be 14.5. So
What does tree
14,
have to be?
14.5 minus 6.5 is 8. So tree has to be 8.
Tree is 8, and now we just need to know our 8 times tables. Find the pig. 8 times something is 576.
72.
72. If anybody was trying that in chat, I hope you got those answers because Blake got them correct. Super job, sir. Okay, that was our couple of warm-ups here. Now that we've warmed up, Blake, it's time to have a quick chat with you, get to know you a bit more. And I have to do something real quick. Oh, there we go. Now we can both see each other, and we can see chat. Okay. So, Blake, you bought a little bit of time earlier. You said you like math.
I do like math quite a bit.
Why do you like math?
Well, been doing math ever since I was little. My grandma always bought me the EMC math books when I was little. Not the EMC ones, but the math books. And then
Beast Academy.
yeah, those.
Yep.
And then some of our friends joined EMC, and we were gonna join another math group, but we decided to join EMC because our friends said they loved it. And since then, it kind of just brought me more and more into math and love it ever since.
Awesome. And I have a quote from you that you may or may not remember saying in my class once. But you said something about EMC being the blank ever. You remember what it was?
Might have said it was the best ever.
You did. You said it was the best ever. Why do you think EMC is the best ever?
Well, in very friendly classes, like you can be very open in the classes. Teachers are super, super nice. And it kind of makes everyone in the class understand everything because everyone kind of gets almost one-on-one attention in the classes. So
That's awesome. Okay. And since I am one of his teachers, he was not paid to say that. Okay. Awesome job, Blake. So, what are some of your hobbies? What do you like to do?
Well, I run track a lot.
Mm-hmm.
So that's definitely a big one that takes up most of my spring. And otherwise, in the fall, I play hockey
Mm-hmm.
for the Sharks Hockey Club. And like that too. I play all my school sports because it's fun to hang out with your friends and things. And I also
Yep.
love photography.
Photography.
So
Awesome.
a lot of travel photography.
How often do you guys get to travel to take those photos?
My family actually travels quite a bit, maybe big trips, maybe 2 times a year,
Mm-hmm.
and smaller trips, maybe just like to LA or something, or like to Washington, maybe around 4 times a year.
Very
So
cool. And you said you play hockey for the Sharks. Is that the San
yep.
Jose Sharks or
Yeah. Well, not the NHL team, the professional team, but their junior teams, yeah.
their junior teams? That's very cool. How or what position do you play, and how many points you got this season, last season?
Well, I play forward and I got quite a bit of points because I'm only playing rec league, which is like
Hmm.
non-travel, so you don't go anywhere. But it's kind of more chill. So I scored maybe 3 a game.
About 3 points a game. Nice.
Yeah,
That's
but
really good. Awesome. Are the scores really high then? Like
yeah,
12?
our scores are like crazy high. I think one game we actually got up to like 32-4. We won
Wow.
by a little bit there.
I think that's a little bit, yeah. Let me do the
But
math on that one. 28 points, 28 goals ahead.
yep.
Awesome. I've got a mini game here to get to know you a bit better as well. So choose or flip a coin. Would you rather, if I flipped a coin, would you choose heads or tails?
Like tails.
Tails.
Yeah.
Okay, we're gonna name something and choose your favorite of the three letters there, A, B, C.
Let's go with B. The name starts with B.
B for Blake. Name one of. If you were to roll a 10-sided die, what would you get?
Lucky number 5.
Lucky number 5. Name one of the most expensive. Pick a card. Any card.
With this, the 4 of hearts.
The 4 of hearts. Okay. Name one of the most expensive games you own. I
Ooh,
see you've got a controller over there.
I do have a controller. Probably the new FIFA game, new
The new
soccer
FIFA
game.
game, how much did that run you?
Well, like when it came out, I think it was $90, which is absurd. But I got it for 95% off, so I got it for like $7, which was a really good deal.
And that's the most expensive game you bought is $7?
Well, I guess I did buy a $60 game, but I did when it just came out, and I do not regret it.
There you go. What about other types of games? Do you have board games or anything else that might be expensive?
Mm, let's see. I think I have some expensive board games. I don't remember what they're called though. I like all those Catan games, which are kind of expensive. Catan, but
Yeah, some of them can be pretty cheap, pretty pricey.
yeah.
Awesome. Very cool. Okay, let's put those back. Round two, I guess we got to go for heads this time. And A is for Andy. Um, my lucky number is 3. What would I pick? I think you know that I would pick the Joker, right? Because I'm just a Joker. Eliminate forever 3 of your least favorite foods. Well, that makes it easier. Um, for me, that's going to be eggplant.
Yeah.
Um, I only like it in baba ganoush. Everything else is
Yeah.
I don't like eggplant in it. Um, what else would I eliminate? My least favorite foods. Uh, I think I tried that jackfruit stuff once. That that
Yeah, yeah.
really smelly fruit.
Yep. Yep.
Yep. I would eliminate that as well. Um, and oh, cabbage rolls. Sorry, Dad. Sorry, Dad. Your cabbage rolls not quite as not quite as good as some of the other cabbage rolls I've had. So I would eliminate my dad's cabbage rolls. I think he just misses some seasonings or something. Yeah. What about you? What would you eliminate?
don't like black licorice too much. It's not very good,
Mm,
my opinion.
so
Then,
star anise, not your
yeah,
favorite spice?
then uh, probably also eggplant. Don't like eggplant. Then maybe like herring. You know those pickled herrings?
Herring?
Yeah, like pickled herring, like the fish.
Yep.
Like
Yep.
love those.
I'm surprised you've even like been forced to eat those at some point. That's not a big popular food anymore. They used to be
Yeah, that's
popular.
when you grow up in a Russian family.
Oh, gotcha, gotcha. Okay, let's do one more. Do you want to eliminate forever or name?
Let's go eliminate forever.
Okay, we haven't done C.
Eliminate
Two
forever.
of
Let's go eight.
8.
Yes.
The grossest.
Uh, two of spades.
2 of spades. Apps. Ooh. Remember, we're we're a friendly stream. So 2 of the grossest apps you've used.
Um, I have no clue.
Yeah, maybe we'll pick a different thing other than apps. Oh, no, you know what? Appetizers. Apps could be appetizers, not just apps on your phone. Okay, what are the
Uh,
2 grossest appetizers?
let's see. I don't love too much like tuna casserole, like sometimes as an appetizer,
Okay.
or like any sort of like tuna paste.
Yep.
Not my,
Tuna tartare, not your favorite?
yeah, no, not too much.
Yeah, I can see that. Um, I would probably get rid of the overcooked. It has to be the overcooked ones because it's usually really good, but they're either over or undercooked. It has to be cooked perfectly. Um, the tempura vegetables.
Oh yeah,
If they're undercooked, it's
they're not.
it's all hard on the inside,
Yep.
and if it's overcooked, it's like too crunchy. Yo, what's up, Blake? Says Alec. I don't know if you have a friend named Alec, but they just said, "Yo,
We
what's up?" in chat.
have a friend named Alec.
Nice to nice to see. Welcome, welcome. Okay, okay. Do you have another grossest app?
Mm, nah, not really. Maybe like I have no clue. There's this Russian dish called what's it called? I have no idea. Something to do with eggplant. Not delicious.
Get rid of the eggplant.
Yep.
Yeah, I would say Ratatouille is another one that I would probably because it's got that eggplant in it. It's not my favorite. Okay, awesome. Thank you, sir, for playing my get to know you game. Okay, we're going to transition now. It's time to do some puzzles. So, this segment, we're going to do some puzzling questions from competition style regions. So, in chat, you can join in, uh, figure out what's going on, and try to get your answer in before Blake and I solve it. Sound good? Okay, Blake. Your friend Alec is watching. He's waiting. He needs to see how good you are.
All
An
right.
apple tree has 15 branches. There are either 7 apples or 3 apples on each branch. Which of the following numbers can be the total number of apples on the tree? Could there be 98, 90, 87, 79, or none of the above? Alex, see if you can beat Blake.
All
But
right.
it's
Let's
not a
see.
race.
15 branches. It can either be 7 or 3. So 15 times 3 is 45. 15 times 7, too much. All right, so none of 8D is any.
So 15 times 3 was 45.
Yeah,
15
that's like
times 7,
minute.
too much. It's 105.
It's our min and our max.
That is the minimum and maximum. So it could be any of these so far. Haven't eliminated them yet.
Well, if we had 14 branches of 7, that would be 70, 98. Then we would have to add 3. So that would be 101. That would be way too much.
101. But what are we jumping by?
We're jumping down by 4. So every time we add a branch of 3, we go down by 4. So it basically has to be a multiple of 4 plus 1.
A multiple of 4 plus 1.
Yes, because 100 is a multiple of 4.
Okay. We got
So
some viewers. We love chats, so viewers, let's see if you guys can beat Blake to figuring out which of these might be a multiple of 4 plus 1. You might already know.
all right. So that means it has to be even. So, or I'm sorry, it has to be odd because it's an even number plus 1. So it's none of these.
Can't be
And,
A or B.
and 87 is 86 plus 1, but 86 is not divisible by 4 because it has a remainder of 2. So it's not this one either. And 79 is 78, which is also not divisible by 4.
Hmm.
So it's none of those. It's
So
E.
your answer is E.
Yes.
Final answer?
Yes.
That is, I don't know. Chat, do you think it's correct or do you get it? He said, "What's up, Blake?" And then I think he might have left. You told your friends you're going to be on a stream. They're like, "Oh, it's about math." Mm,
It was
mm, yeah, he got it right. That is correct. Okay.
woohoo.
In airplane luggage, the 2 lightest suitcases together weigh 15% of the total weight of the luggage. The 4 heaviest weigh 75% of the total weight. How many suitcases are there?
Lightest, 4 heaviest. All right. So, well, we have the 2 lightest and the 4 heaviest. So 15 and 75 make up only 90% of the suitcases,
Mm-hmm.
which means that we need 10% of the suitcases more. And we have so far 6 suitcases. So 6 suitcases equals 90% of the weight. And then let's see, the 4 heavy suitcases weigh 75% of the total weight. Suitcase right there. Wait, would it be possible that the 2 lightest, one of the heaviest is also part of the lightest? Wait, no,
Could.
that wouldn't be possible because then you would have less than 100%.
Mm-hmm. Well, more than 100% would be represented if there was overlap.
Oh, yeah, that's what I mean. So we need another amount of suitcase.
More suitcase.
More suitcase.
If you're a
So
new viewer, please say hi in the chat just so we know who's here. We're looking to beat Blake. A, B, C, D, or E. He's trying to figure this out. It's the Beat Blake segment. He can't see chat, so he won't know. He won't know what your answers were. You can't steal them. Okay, did I buy you enough time to think about it?
I think so.
Okay.
So if 6 is 90%, then 10% is divided by 9. 6 over 9, which is 2/3. So we need 2/3 more. That doesn't work.
Hmm.
Hmm. Huh.
6 suitcases have 90% of the weight. 4 suitcases have 75% of the weight. And 2 suitcases have 15% of the weight.
Yeah.
What's the lightest? These are the 2 lightest suitcases. What's that tell you?
What do you mean? That 15% is like, hold on, what do you mean by that?
Well, if I have the 2 suitcases are these 2 suitcases are the lightest they can be.
Yeah.
Okay. What does that tell me?
And the other suitcases have to weigh more
The
than
other
those,
suitcases have to weigh more than what percent?
than 15%. Or
Than
no,
15.
then let's 7.5.
They have to weigh more than 7.5%.
Yes.
That's the
Oh,
small. That's the smallest this could be, is if they were both the same size and taking up half of it.
yeah.
Okay.
So that
What's the
if you
biggest
need
they could be?
the biggest, um, well, 7.5 times 5 is 35, 37.5. Minus 9, or 90 minus 37. My bad. So
It's okay.
10. Wait, no, that's the lightest they can be. I'm sorry.
These are the heaviest suitcases.
Yeah.
So if
It could be like 52 at the heaviest, 52% ish.
what
No?
what math are you doing?
Like one suitcase at most of the heaviest ones can be 52% of the weight.
Because you have
Because they have to like wait, because the other three have to weigh more than 7.5.
okay. Alex saying goodbye. Have to go. Blake, see ya. Peace
Bye-bye.
out, Alec. Thanks for joining us. Thanks for watching.
Well, back to 7.5%. If
Yep,
you have 90%, you can only add 7.5 once. If you add it any more times, it would be a little too heavy.
they would be overlapping with the
Yeah,
75, right?
yep. So I believe you can only add one more suitcase.
Okay. So if we can only add one more suitcase, how many suitcases are there?
7.
7 is correct. Great job, sir. Okie dokie. Next problem. Another kangaroo. Let's do this one instead. The following bar graph shows the number of cups of tea drunk in a day in an office of 21 people. What is the median number of cups drank by the people at the office?
Well,
Drinked.
to find the median, you kind of just find the middle of all the set. So if you would have written all the numbers out, like in growing order, you would just cross them out into the middle.
Yep.
So here you can cross out 4 on this side. Let's say 4 on this side, and
Mm-hmm.
then 5 on this side, and these 2 and these 3. So 5 on this side. Then 1 here, 1 here. So this is our median.
This
So
guy's a pro. This is what I brought him on for. I didn't even think of it that way.
that's what I always do for medians. I just cross them all out.
Cross them out until you got what's in the middle. And it worked. 6 is the correct answer. Fantastic job. Okay, we got some viewers coming and going. Say hi if you're in chat. Sorry, and tell us if you got the answer before Blake here. Just put the letter in. He can't see it. A squad at a camp has the same number of girls and boys. 4/5 of all the girls and 6/7 of all the boys were out for morning exercises. What proportion of the campers at the exercise were girls?
All right. Well, if 4/5 of all the girls went out, that means 1/5 stayed behind and 1/7 of the boys. So there's obviously, well, not obviously, but there's going to be more boys because a smaller fraction of them stayed behind.
Mm-hmm.
Um, I believe we can just divide 6/7 by 4.5. Would that work? I believe that.
So you want a fraction that's over a half? Was your initial conclusion?
I think that would work. You get 30/28, which would give you, let's see, 30/28 is what portion of the campers at the exercise with girls? Oh, portion. I
Proportion,
see.
yeah.
You mean like what fraction of them were girls there?
Yep, proportions and fractions are very closely related.
All right. So if at this
They're like
like
besties.
if at the exercise this is 4/5 of the girls and this is 6/7 of the boys, then and it's the same amount, we can say um well, I guess you could just divide them, couldn't you? Multiply one by the reciprocal.
Mm-hmm.
So you would flip this one. So 5/4. You have 30/28, which is none of those.
Mm.
Oh, no, you would flip the other one because you need to find out the girls. So it gets a smaller number, I believe. So you get 28 out of 30, which would give you 14 out of 15. Or none of those again. Hold on. My brain is
That's
making some
okay.
um 4/5 all the girls, 6/7 for all the boys. Let's see. It'd be somewhere around a half because 4/5 and 6/7 is pretty close.
Okay. So it's could be D,
Yeah,
C,
let's
B,
just cross
but
out.
not A or E, right? It's got to be close to a half.
Yes.
Okay. And that's because these fractions are close and they were equal.
Yes, and since more boys went out, it can't be a half, but it could be one of those two because they're both less than a half.
Mm-hmm.
And let's see. Let's just say there's 35 girls and boys because it fits into 7 and 5
Okay.
because 5 and 7 fit into them. So that means 4/5. So 28 out of 35 girls would go. 28 out of 35 girls would go, and 6 out of 7. So 30 of the boys would go out of 35. Then this, and then those together are 58 out of 35. No, wait, hold on. What portion of the campers at that exercise were girls? Um, I'm missing something here. Something very easy. missing here?
What are you missing?
I don't know. Hmm. This is 2/35 less.
How many campers are at the exercise?
Um, Total?
Mm-hmm.
Oh, we don't know.
Yeah, we do.
But they're
In your scenario, if there were
oh
35.
in my scenario,
Yeah,
58, 58,
58. And how many of them are girls?
28. Oh. All right, so it's B because this is equal to 14 out of 29.
Well, there you go.
Come on.
Good job, sir. B was correct. Okay, last puzzle of the day. The rectangle FADE, F-A-D-E, is a 9 by 12 rectangle where AB equals BC equals CD equals 3. What is the area of the shaded region?
Let's see. Well, the whole rectangle is a 9 by 12. So that's 108.
Mm-hmm.
So the whole entire rectangle is 108. And let's see.
No, pencil's too big. Area of FADE is 108.
Yes. And then this 3 by 12, we can find this hypotenuse, which I think would help. So 12 squared is 144 plus 9. That's like 144 plus 9. That's 153.
Root 153.
Yeah.
Do you think I'm going to do that to you?
We know that this side plus this side squared equals 153.
Mm-hmm. Do we?
So this,
Do we? Is that a right angle?
that is not a right angle. That's my bad.
Mm.
Um, Here. Mm, what else?
Mm.
I'm looking at any way to break it up somehow.
This one is harder than it looks. Okay,
Is it
Blake, where, what do I know? Always good to label what I know is for sure true.
that the whole area is 108?
Okay.
That, let's see,
What about the area of these triangles?
them together will be 36.
3 times 12 is 36 over 2, but you combine them to make a rectangle. So we're going to take away 36.
So these triangles, no, we
Mm-hmm.
don't know.
What do I know about FE?
That it has to be 9.
What do I know about this angle?
It's the same as this angle.
Mm-hmm. What do I know about this angle?
that is the same as this angle
How do I know it's the same as that angle?
because this angle in the middle is the same and it's equidistant on the sides. Yeah,
Equally distant, so it's reflective.
yeah, that's
Okay.
what I meant.
Yeah, I like it. So I know I have an isosceles triangle. What about up here?
Also an isosceles triangle.
Do I know anything about these angles?
Oh, it has to be the same as the bottom ones because it's what the vertical angles, not vertical, but like the same as the bottom ones. So that
Because we
top
have
one, the three on the sides missing.
parallel
Oh, yeah, 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 yeah.
line theorems. We've got alternating interiors.
Yes.
Okay,
All right.
so
So
what can I say about this triangle and the top triangle?
the bottom triangle is three times bigger than the top triangle.
Okay, so area of single dot
Yeah.
equals, so 3 times that.
Yes.
Is it area or
Well, yeah, area, I think. No, it's not area. It's like the base length.
it's the base length?
Yeah.
Okay, so what's the relationship between the triangles? They're
They're
what do we call that?
similar.
Similar. Okay, so let's call this point M. Okay, BCM is similar to
What?
what
Which point?
order?
Oh,
BCM,
FCE. Oh no, 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 no. FEC.
FEC. Okay,
Right.
I know they have a 3-to-1 ratio. So what do I know about the ratio of their heights?
That's also 3 to 1. Oh, okay. So if let's say the height of this one is also 3, the height of this one has to be 3 times more, so it's 9. That works since it adds up to 12.
Okay, so now we just have to subtract these two. What's the area of
3 times 3 divided by 2 is 4.5.
4.5?
And then 9 times 9 divided by 2, that's 40.5. So that gives us 45 in total.
Okay, so we're going to subtract 45 and 36.
Yes, that's 781. And 108 minus 81 is 27.
27. When in doubt, guess C. No, don't always guess C. That's probably a bad idea.
You should guess B instead.
Guess B instead. Yeah, they probably threw you off. But yeah, excellently done. We just had to realize that these two triangles were similar
Yeah.
because of angle angle. Okay, and so you can see that from parallel line theorems and vertical angles there. Great job. Okay. Would you like to play a game, Blake?
Sure.
Okay, it's time to play Spot 6 Differences. Why do we play this game?
Plot difference as an equation.
Yes! I taught him well. If you can spot differences between birds, you can spot differences between your equations.
I never thought about it that way. Thought we always just did it for fun.
Oh, nothing you do for fun in EMC has no purpose. There's always a purpose. We always have fun for a reason. Yeah, if you can spot differences between two things, you're looking for visual patterns, you're going to need to do that at some point. We talked about that yesterday with Victor. He used it in his job all the time when he was programming.
That's a big.
Okay, what you got from you, Blake?
All right, we got this eyeball.
Oh, the eyeball is one.
We got this kind of hemisphere here. Oh, what else do we got? How many
The
differences?
moon atmosphere, or whatever that is in the background.
See, all the leaves look the same. I want to say, yeah. All right, what else is different? Let's see.
Anybody watching in chat, feel free to let us know if you see a difference. We'll circle it for you.
Right here's another one. Let's see.
Yes, sir, the flower has lost its things in the middle of a flower. I'm not a biologist.
They're called like stomatas or something.
Something like that.
Something like that.
The shading on the log has changed. That is correct.
Let's see. What else?
Anyone else see a difference?
I'm stuck. I need some help.
Hmm?
I need
You
some
need
help
some help
from the chat. From the chat.
from the chat? Blake needs help, chat. Can you find the two that are left? I think we have some lurkers. They might not have the ability to chat. We call those lurkers online. People who don't chat, but
Just,
watch.
just here for the
They're
vibe.
lurking in the shadows.
Let's see. Oh, it's a spot on my screen.
So there is another, well, there is a change on one of the leaves
One of the leaves
and somewhere else on the bird.
on the bird. Wow, this is going to be difficult. Oh, you see it.
Yes, yes. On the tip of the leaf and on the side of the wing all the way down. Oh, very nice, sir.
There's like a tiny sliver of the answer key shining through the side of the slime.
This is how the sausage is made. Okie dokie artichoke. One more of those. And then I'll do my live video recording. We'll say goodbye.
Right off the bat, there's this one. Let's see what else is obvious.
3 berries.
This one.
The center of a flower.
What else is there missing?
6 differences here. See if you can beat Blake to finding them all.
Ooh, there's one right here on the leaf.
Mm-hmm. Maple Leaf got scrubbed. It's on that one on the answer key.
You see the side of it.
Just barely. Just barely.
Ooh, 3 more berries right here.
Berries. Missing berries. We got 4 out of 6, 2 to find.
Yep.
1 is very hard to find, especially on small devices.
Oh.
A very slight color change.
Color change. Whoa, wait, there's one here. There's a hungry squirrel.
Hungry squirrel at the top of that acorn is correct. The last one is on a green leaf.
A green leaf. My goodness. Close to it. Oh. I looked at that leaf 20 times.
You did, but this one has little veins on it that are very hard to see, and this one does not. Great job, sir. Okay, Blake, thanks for joining us today.
Thank you.
I hope you had a lot of fun learning with us,
I did.
practicing math with us, and we'd love to have you back in the future if you can make it.
Yeah, of course.
Awesome. Everybody in chat who's still here, say bye to Blake. Bye.
Bye. Thank you.
And up next, we're going to do a live video recording. Oh, chat says, great job. Keep this good energy up. Looking forward for the next time. Have to start driving again. Okay, no problem. Okay, bye, Blake. It was nice seeing you. Bye. Get myself back up in here. Okay, our last segment of the day is a live video recording. So what this is a quick lesson of something targeting our age group for today. So that was 7, 8, 9. And we want to keep this segment, we want to put it onto YouTube. So it's going to be just like a relatively quick clip today. So we're going to have a shorter stream today. But we definitely had a lot of fun with Blake. And so I'm just going to take a quick break to get some water so I can do this lesson in a second. Thanks for joining us so far. I'll be right back. Okay, everybody, welcome back. We're going to get started with our live video recording in a second. I just wanted to make sure everybody was aware that you can find us online as well at emc.school, where you can find different programs for different types of students, and hopefully you'll find one that you like for you. Okay, today we're going to be talking about transformations. So a transformation, there are different types of transformations, but in math we have a specific type of transformation called transformation that transforms functions into other functions. Okay? Transformations can include moving the graph up, down, left, or right, just kind of sliding it around, but not changing what the picture looks like. Okay? Or it could be expanding and compressing the graph. So it could make it bigger, or it might make it tighter, or stretch it vertically or horizontally, squishing or stretching. Or it could reflect it, could turn it around, like I was doing with my hand there, or any combination of the above. Okay, what function transformations have you seen before? Okay, each of these has a name. If you know, so when you think about shifting or moving graphs of lines or parabolas or other functions up or down, what part of the equation would shift that up or down? So let's think of a line first. We have y equals mx plus b. What part of this will shift it up or down? If you said B, you're correct, because I'm always adding some amount, B amount, to the mx. So if I'm a line and I add the same amount to every part of the line, mx, I'm going to go up or down, depending on how much I'm adding or subtracting with this B. Okay? And if I have a quadratic, say I have y equals ax squared plus bx plus c, what part is going to make it go up or down? Well, again, if you said plus c, you're correct. This is going to change the slope of the x component. This is going to change the width of the x squared component. And this is going to move it up or down. Now, in order to see how it would shift left or right, we want to look at this in Desmos. Okay, so here I have a function, x squared plus sine of 3x. If you don't know what sine is, that's okay. It just makes makes some things wavy. Okay, so we're adding a wave to our regular parabola. Now, if I think of the function being transformed to g of x, if this is my original function f, we already talked about how the plus at the end, the plus d, is going to make it go vertical or horizontal. So see how when I shift this down, it moves the whole function up or the whole function down, depending on the magnitude and direction of d. So what do you think will happen when I change a? This is the one on the outside that's multiplying the whole function. Okay, it's multiplying x squared plus sine of 3x. The whole thing is getting multiplied by this value. Okay, well, let's start by making it double. What happened? Goes from here to here. We've got that stretching action. It's stretching vertically. Okay, and that's because f is the function, is the vertical component of the graph. And I'm multiplying that f by a number. So if I multiply every number by a big number, it's going to stretch it a lot. If I multiply it by a small number, almost 0, it's going to look more and more like a parabola because the wave is not doing as much. Because I'm minimizing the effect on y. Okay, and if I make it negative, -1, I get that reflection. Okay, so A is both a reflection about the x-axis, okay, but it's also a reflection about our point. So let me put this back here, D. You can see the reflection about the axis better when it's at 0. Okay, but -1 flips it right upside down. Okay, and we're going to get a stretch just like we did before if we get bigger and bigger negative. But it's upside down when we stretch it. Negative, very small, is just like that parabola before. If I have 0 here, the function is now 0. I multiply everything by 0, so I'm just going to get y equals 0. Let's bring this back to y, or a equals 1, so that it's not affecting the problem at all. Now let's look at this b in here. So I'm multiplying x minus c by a number. I'm multiplying my entire input by a number. What's going to happen there? If you said you're going to get a horizontal stretch, you're correct. Because I'm doubling what I'm putting in to the function, it's going to get to the same point vertically faster. So I'm compressing where it's going to happen. If I make it a small number, but bigger than 0, it's going to stretch it horizontally until I get to 0. Then I get y equals 0 again. And if I have a negative component, -1, what happened there? We get a reflection about the y-axis. That's right. So this is a horizontal stretch. The b is the horizontal stretch and can cause, when I flip the negative sign, can cause a horizontal reflection. Just like a is the vertical size stretch, vertical stretch, and if I go negative, I get a vertical reflection. So A and B are like opposites of each other. So what do you think C is going to do? Subtracting some number from x before I multiply it. In this case, I went back to 1. Okay. If you said it's going to do a horizontal shift, you're correct. Okay, so it's going to, I'm just telling it to get to this value of x sooner or later, depending on what I'm adding or subtracting. So this value of x is going to move over, but so is every single other one. Everything's going to shift over by 0.8 because I've moved the whole thing 0.8. I'd move this point by 0.8. I moved this point by 0.8. I moved this point by 0.8. So every point gets shifted by 0.8 away from the original. Okay, so we get that C is horizontal shift, D is vertical shift. Combined with C, we can move it on a diagonal. Okay, B is a stretch horizontally, or reflection with a stretch, and A is a vertical stretch, or a vertical flip. Let's hit play on all four. See what happens to our beautiful function. It gets flipped a lot. Every time one of them is going from positive to negative, we see a flip for A and B. Anytime it's going positive and negative in C and D, we're going to go above or below where we started from. And that is the basics of function transformations. Hope you enjoyed the video, and hope you enjoyed the stream, and I will see you guys later. Have a great day.